Hello everyone, good morning. This is Ajay and I am a CNC machine training faculty working since last 10 years. Today this video is on the topic that called as a speed fit calculation and find out the cycle time required for particular jobs. This video is useful for those are the ITR, diploma, degree engineer or those are working in the line of machining being as an operator, setter and programmer. For them this video will be a knowledge gaining video surely. So let's start with the topic that called as a speed fit calculation. Now suppose this is the job, this one is the job and this job is with the diameter 40 and I have to cut with the length of 100 mm. Now being working as a training faculty, normally we get this question, sir बताइए इस job के लिए RPM कितना रखा जाएगा. We used to get a phone from our ex-student and they tell, sir मेरे पास में ये job आया हुआ है and this is the diameter, please tell me what will be the RPM. My reply to such question is always, don't ask me in a value, ask me how to find it, ask me factor depend on. So same thing I am going to tell you, don't ask me in a value, I will tell you how to find out and factor that to be considered while calculating the speed fit. Let's start up with, now I said this is the job with the 40 mm diameter with the 100 mm length. Very first thing that you must know is called as that cutting parameters depend upon so many factors, and that is here. Very first thing that is called as a job diameter and second thing is called as material hardness. Unless and until you don't know about these two things, you can't find out the speed fit calculation. Now suppose I consider this is the job with the material of stainless steel, and normally this material is called as a very hard material and it is with the 55 HRC, it's indicating the level of hardness. Above 50 it is always called as a very hard material. Once you come to know these two things, the third thing you have to find out is that called as a tool available. Right now I call it as a tool available. It means I have one tool available with me. Suppose I call this tool TNMG 160408. This tool, it is coded like this, TNMG. Then the next factor you have to find out is which company tool you are using. There are so many tool manufacturers in the market like Seiko, Sandy, Nvidia, Corloy, and again so many tools. You have to decide which tool will solve your purpose according to cost and according to the types of production activity. Suppose I consider right now my tool is of Corloy company. Corloy is one of the good tool manufacturers and this tool mostly get used in the industry. Then the next one, it is called as the tool grade. What is tool grade? Suppose here it is tool grade is 5300. Tool grade is nothing but the product developed by that tool manufacturing company according to job material. When tool manufacturer develop the new tool, they develop according to material. If develop a tool, that tool will get used with the various material, but it vary with the speed fit. They add such a material suit for the, suppose you want to cut the steel, so their tool will contain such a material which is good for the steel. So they define it as a grade, and grade is nothing but a product they develop for particular material. Once you come to know these things, you finalize that you have to use the tool Corloy and with this grade. Now your tool manufacturer will suggest you at what speed fit you can use this tool, and that is called as a cutting parameter. Refer the insert box, and cutting parameter always suggested by the tool manufacturer. So referring the insert box will come to know, as we already said, this is a TNMG tool with this grade of 5300. Now what that PMK stand for? It is called as a material ISO coding. Your tool manufacturer will suggest you whether this tool to be used for the steel, stainless steel or cast iron. P is called as a steel, M is called as a stainless steel, K is called as a cast iron. Sometimes if this is given, it means this tool can be used for the steel, stainless steel and cast iron, but sometimes they may particularly mark this on a P only. It means that you have to use that tool only for the steel, not to other material. And for steel, you can use that tool for such size of material and material condition with the VC equal to 200, FN equal to 0.2 and AP equal to 1 mm. This is called as a cutting parameter. What is the meaning of VC? VC is called as a material cutting speed and it is always suggested by the tool manufacturer. FN is called as a feeding mm per revolution and AP is called as approach, and approach means depth of cut. By using these three cutting parameters, we have to find out very first thing that called as RPM. And to find out the RPM, there is a formula, and formula is N equal to Vc into 1000 divided by pi into d. What is the formula? Vc into 1000 divided by pi into d. But somewhere in the books and somewhere in your reading, you will find that formula will be like this: Vc equal to pi dn divided by 1000. But this is the formula for the Vc, and Vc is given. N means RPM. N means RPM, which is unknown. That's why we alter that formula. Is N equal to Vc into 1000 divided by pi into d. Now, what is the thing is given? Vc is given. D is the diameter. Right now, this is the job with the 40 mm diameter. If these two things is given, we can find out the RPM. And to find out the RPM, you have to write the value like this: Vc 200 into 1000. Pi value is constant value, that is 3.14 always, and into d. So this is the diameter of 40. If you just use the calculator, 200 into 1000 divided by 3.14 divided by 40, you will get answer, and it will come around 590 or even in some points. But RPM always you have to write in. You can't write RPM in a point. You have to write in a round of figure. So I make it 1600. This 1600 is the RPM required. RPM required to cut the job with the 40 mm diameter. So this is the way to find out RPM. The next thing that we have to find out, what time will be required to cut this 40 mm diameter with the 100 mm length. That is called as the cycle time. Now to find out the cycle time, now if you want to find out cycle time for this job, three things is required. The first thing, what is that? Length. Length is of 100. Second, at what field you can cut it. Field is given here in the insert box. It is 0.2 mm per revolution. The third thing, that RPM we already find out, and it was taken as a 1600 RPM. To find out cycle time, these three things must be known. What is the length to be cut, at what field tool will approach, and at what RPM job is rotating. Now, how to find out? According to the field given, it's saying that 0.2 mm per revolution. What is the meaning? Your tool will travel 0.2 mm in one rotation. One rotation of the spindle. Means when the spindle will take one rotation, tool will travel 0.2 mm. Again one revolution, 0.2. Again one revolution, 0.2. So if it travel 0.2 mm for one revolution, we have to totally travel 100 mm. So if it is 100 mm to be traveled, 100 mm to be traveled, how much rotation will be required? Just find out it. And how to find out? Make a cross multiplication. You can just multiply this like this. So it will be like x equal to 100 divided by 0.2. It will come around 500 revolution or rotation. It means to cut the length of 100 mm with this tool, with this speed, it will get cut in a rotation of 500. In a rotation of 500. It means for cutting of this job, we require 500 rotation. Now, RPM given is 1600. It means 1600 revolution. RPM always count per minute. Means 60 seconds. Means 60 seconds. Means your job will rotate with this much rotation in the span of 1 minute. But we are looking for rotation of this much only. So if we want only 500 rotation, what will be the time required? So again cross multiplication. Again cross multiplication. So that will come around 500 into 60 divided by 1600. Again use the calculator. 500 into 60 divided by 1600. It will come around 30 seconds. 30 seconds. It means to cut the job of 100 mm length using this tool with this field rate and with this RPM, this much time will require. But this time required is for one pass only. For example, we have shown how to find out. We have just taken, it is a job with the one cut only. If this is the material Like if it is the job is of 50 mm diameter, you have to reduce to the 40. It means with the 1 mm depth of cut, we have to cut it with the 5 passes. So multiply that 30 seconds into 5. That is the time required for the 5 passes. But this is called as a cutting time required. It's not a job cycle time totally. Now to consider job cycle time, for job cycle time we have to consider a lot of things. With that, your tool will travel from this point to this point. This is also one of the movement, but it is called a rapid movement. Then it will start cutting. So cutting time we already find out. Then your tool will lift, again it will get back, again it will start second cut. So that all movement, which is uncutting movement, but it is a movement. It means it will require some time. But sometimes this is a negligible. Why it is negligible? It depends upon your machine. With the today's, the machine rapid with the 12,000 mm per minute, 20,000, 40,000, even Haas control, Mitsubishi control, and Mazato control. They are making the machine with the rapid of 40,000 mm per minute. But we can't use that much. For 1 or 2 cut, that rapid will be very negligible, 1 or 2 seconds, because it comes very fastly and it will get back. So in that case we can neglect it. But if your job is of too much material to be cut, number of passes, the lift need to be there. Tentatively it may be 10 or 15% of your cutting times. That you have to add. So if I say the cycle time for the one pass is 30 seconds, accordingly 5 or 10 seconds you can add. So that will goes to the 40 seconds. But that is not again sufficient. Again, what factor to be considered? The third factor to be considered, if your job is of now this 40 mm or 50 mm, you can easily load, start, it will be. So loading and unloading time is here very negligible. But with the sum of the job, if your job with the 500 mm diameter, 1000 mm length, so sometimes loading and unloading time is more than cutting time. But that you have to count in your cycle time. Sometimes your job with some special operation, and due to the need of customer demand, you have to check each and every size out. There are some critical dimensions like bore size. You have to go with the air plug device, or you have to check with the thread plug, and so many other instruments to be used to check the job. That time, that checking and inspection time to be also added. Like that, there are so many things. Again, fatigue of the operator. If you are working for the 8 hours a day, it is not possible to count 8-hour production. Normal industry consider for the 8-hour shift, it count as a 7-hour production only. So that is called as a rest time, lunch time, human fatigues that need to be added. Then accordingly, once it is, suppose we consider if this job will the 5 passes and cycle time come around 2 minutes. So overall we come to the conclusion that this job will require 2 minutes of the times. So what will be the rate? Now again, rate will be depend upon so many factors we consider. Now if it is a job is called as a turning job, so machining rate for the turning for the production activity, if you are there is only one job to be developed, the cost for one job will be vary. If it is a continuous production, that time it will vary. When it is a tool room activity, material is very hard and very heavy job, rate will be different. Normally for the production, machining hour is taken as a for the CNC turning. What I know about is 200 to 250 rupees per hour. Now, as per our calculation, for this job, for one job, 2 minutes will require. It may within the 1 hour we can make around 30 around, and with that 2 minute cycle time, we have almost considered every factor. It means for the 1 hour we are going to make 30 jobs, and rate for the machining is 250 mm. 250 rupees per hour. It means 250 rupees for 1 hour means 60 seconds. Therefore, for one job. So according to this, we are going to produce 30 jobs in 1 hour. So you have to make 200 divided by 30 jobs. So again it come around 6 rupees something paisa, suppose 33 paisa. Around 6 rupees will be the cost of that jobs. But it vary with. This is for the turning, same way for the milling, drilling, other operation also. So the video was to give you an idea about how to find out the speed, then how to find out the cycle time. With the CNC turning, feed is always given. We are not required to find out the feed. because with the turning field is always given in mm per revolution. In case of milling, field can be in various different unit like feed in mm per minute, feed in mm per teeth, feed in mm per revolution also. But with the turning, it is necessary you have to keep the job rotate. That time only we can feed the tool. So always the feed unit given is a mm per revolutions. I hope this video is a knowledge gaining and you will use while you are working in the line of machining, or those are the ITI diploma degree, those are going for the interview. That time such types of questions always get asked. So if you like this video and you feel such types of technical videos should be always given from our side, so we are ready for that. But for that you have to definitely appreciate our effort, and we are expecting you have to like this video and share it if you like it really. Thank you very much. Have a good day.